Let's talk about building privacy preserving applications with zero knowledge proofs. There's an increased emphasis on privacy and transaction efficiency in the decentralized application space. If you would like to participate by creating an application that implements zero knowledge proofs, then you can use a Snarky.js library by Mina, which allows you to create ZK apps using TypeScript. I recommend you watch my previous video about ZK proofs, but also watch this video to the end before you move on to the ZK app coding tutorial. And of course, hit the like button and subscribe for your favorite blockchain dev. In case you didn't know, Mina is a layer 1 blockchain, but what makes it unique is the fact that you can create smart contracts that allow you to write ZK proofs, and its blockchain size is constant at a size of 22 kilobytes. A ZK app has two parts, the smart contract and the UI, which is the front end where users can interact with the smart contract. Imagine you have a file called smartcontract.js, and this file you will write something called a circuit. A circuit is a sequence of logical operations that can be performed on private input, and it generates a public output. Remember, a zero knowledge proof allows you to prove that something is true without revealing anything besides the fact that the statement is true. So a circuit allows you to generate a proof of some statement without revealing the private inputs, which is the information that proves that the statement is true. So the public output is just going to be the fact that this proof is valid, which means that the statement that the proof represents is true. In more technical terms, a circuit consists of a prover function and a verifier function. The prover function accepts private inputs and creates a zero knowledge proof. The verifier function will use it to verify the proof without needing to know the private inputs that went into the proof. The verifier function makes sure that the proof passes all of the constraints generated from the prover function. So in the case of a ZK app, the developer is responsible for creating the prover function, which defines all the constraints. The Mina blockchain acts as the verifier and runs the verification function. Okay, so let's use code to accelerate our ZK app understanding, because code is law. In this example, you are writing a ZK app that only maintains a variable that can be updated by the cube of whatever that variable is. So if the current variable in the contract is 3, the cube of 3 is 27, so only if you submit 27 to the smart contract would it be able to update the variable to 27. So what are you verifying in this function? Well, firstly, you're verifying that the input, which will be private to all the other nodes in the blockchain, is actually the cube of whatever variable is stored. So in the ZK proof, that is what you're going to try to verify. Because remember, the ZK proof is written by you. You're writing the prover function. And in the prover function, you're defining the constraints or the criteria that's necessary to update the variable in the smart contract. As a developer, the way that you define constraints is using assertions, which is very similar to test-driven programming if you've done that. Let's look at an example of a prover function that you would write for this code. So in the update function, you get the current state, which is stored in the smart contract, and that's a number. When we use an on-chain value, we have to prove that this is the on-chain value. So the line that says this.norm.assert equals current state is where we're proving that the on-chain value is actually the value we have as we're processing the smart contract off-chain. Then the function checks whether the number the user provided is the cube of the current state. Once the constraint is met, the function moves on to the following line, which says this.norm.setCube, which updates the state of the smart contract to include the new cube. When a user invokes a method on a ZK app smart contract, all assertions must be true in order to generate the zero knowledge proof from that smart contract. Data passed as input to the prover function is private and never seen by the network. So no one knows what the valid cube number is except the person who was last able to update the smart contract with their transaction. Common assertions that you may use when writing a ZK app are assert equals, assert bool, assert less than, etc. While the state of a ZK app is public, method parameters are private. When a smart contract method is called, the proof it produces uses zero knowledge to hide the input and details of the computation. So the only way the method parameters can be exposed is only when the app explicitly exposes them. Let's say the state of the smart contract is called num, and then you have a parameter is called input num, and then you have a line that says this.norm.set input num. Then that input num will now be stored as the state of the smart contract. So that's an example of how you can make something that was previously private now public. So that's why earlier we said that the level of privacy that you actually achieve depends on the quality of the ZK app. Because if that number should not be made public, then it should not be set as a smart contract state. Just like Ethereum smart contracts, when you're creating a ZK app, you can actually call other smart contracts within your app. Unlike Ethereum, smart contracts on Mina are actually executed offline. The result of the off-chain execution is the transaction, which is then sent to the Mina blockchain so that the changes can be applied to the public net. These are two very important facts about smart contracts on the Mina protocol. The data that a user submits is private to a blockchain. Less gas fees will be wasted in failing transactions since the Mina blockchain only accepts transactions where the proof is valid. It's worth noting that the level of privacy achieved is based on the quality of the ZK app implementation, which is why it's very important to understand these concepts. Now that you've learned the basics of a ZK app, in the next video, I'll teach you how to actually create your first basic ZK app on the Mina blockchain with TypeScript code. Comment if you have any questions down below. Don't forget to subscribe so you get more content like this, and see you in the next video. Bye.